You wake up in your ultra-modern dwelling, go out on the balcony, and admire the incredible sandstorm in the distance. The reddish wall is approaching and has already reached the parking lot where your shiny Starship rocket stands. When the storm subsides, you put on your spacesuit, get in your rover, and drive to work. Your job today is to monitor the instruments in the freshwater extraction plant. In the evening, your shift ends and you return home. The cooking robot has already prepared dinner, fried potatoes, grown right here on Mars. This scenario could be true as early as 2050 and even sooner. Elon Musk plans to send 1 million people to Mars by then. Very ambitious, but incredibly difficult to accomplish. Flying to Mars is very expensive and time-consuming, and it consists of several stages. We're heading to the launch pad, where the first Starship is being prepared for takeoff. The rocket consists of 2 parts. The first is the Super Heavy booster. It'll help the heavy craft overcome the Earth's gravity and leave our planet. It should take Starship into orbit, then undock and land back on Earth. At that time, Starship has to hover in orbit, having used up almost all of its fuel during takeoff. The next step is to refuel Starship right in orbit. The booster takes off again from the launch pad and carries fuel for the main spacecraft. Starship is still empty because we don't want to spend a lot of fuel to lift it out of orbit. So now, it's time for another booster rocket to carry a payload for Starship. Food, construction materials, and research equipment are stacked in the cargo bay. All set at last, our spaceship sets off on its long journey towards Mars. This is how just one ship is planned to be launched, but it can only hold 100 people, while we're planning to send 1 million there. That's almost half the population of Brooklyn. That means we'll need at least 10,000 ships for the whole mission, and even more booster rockets to refuel and send cargo into orbit. Considering that one Starship costs about $8 billion, this mission would cost a pretty penny. The key to solving this problem is reusing these ships. Once the ship has delivered people to Mars, it should be refueled and sent back to Earth for the next batch, sort of a space bus. Another problem is time. The orbits of Earth and Mars aren't perfectly circular. They're of different lengths and make circles around the Sun at different speeds. When Earth and Mars are at their farthest apart, the distance between them is about 248 million miles. And the closest distance, when the Earth is perfectly between the Sun and Mars, is 34 million miles. This is our target. Once every 26 months, Earth and Mars meet at this distance, so this is the perfect time to launch a rocket to keep the flight time as short as possible, between 6 and 8 months. If the first flight is scheduled for 2025, and we plan to complete the mission in 2050, we would only have 12 such flight windows. We would need to launch at least 833 ships in each window. Then there's weightlessness. On a trip to Mars, astronauts will spend more time in zero gravity than people now spend on the International Space Station. Without gravity, people's muscles weaken. Even the distance between their vertebrae slightly increases. So, during the missions, astronauts actually become a bit taller. Throughout the voyage, the team will have to constantly train in the gym to be ready for the hard work upon arriving on Mars. In addition to ships with people on board, cargo ships will also be needed. When people arrive on Mars, they will need to build an entire city from scratch. Construction materials, tools, machines. The massive cargo Starship can take on board is about 75 tons. That's about 30 SUVs. So, we'll need a lot more ships to get everything we need. And that doubles the cost of the whole mission. There's a cheaper way to get to Mars, though. The Gateway Station on the Moon. It's kind of like the ISS, only it orbits our natural satellite. It'll also have many modules for astronauts, living bays, storage bays, docks for ships, and research units. The whole point is that it's much easier for a spaceship to launch from such a station because there's no gravity. And then, the ship doesn't have to use an incredible amount of fuel to leave the Earth's atmosphere. It took about $100 billion to build the ISS, and building Gateway could be even more expensive. But it should save us money in the future. The small Orion spacecraft will lift astronauts from the surface to the station. Then, after preparation, the astronauts will go on a long journey to Mars. Let's go a little bit forward in time. The first few ships have delivered their load on the surface of the red planet. Beach umbrellas and deck chairs will have to wait because it's time to build the city and prepare for the arrival of the next group of people. The priority is energy. For this, we can use solar panels like on Earth or nuclear power plants. The next step is to build houses. Because of the lack of atmosphere on Mars, nothing will protect us from the sun's radiation. So a great option is to build houses underground. Now we need to take care of water extraction. There are ice caps at the poles of Mars. We can take water from there. Then, oxygen. Plants have to help us do that. There's a lot of carbon dioxide in the air of Mars, which serves as a kind of food for green plants. And as a waste product, they release oxygen. All we have to do is collect this oxygen and use it to breathe. Sooner or later, the food we bring with us will run out, so we'll have to grow food directly on Mars. This requires fertilizers and greenhouses. Now that everything else is taken care of, the main task is to produce fuel. We need it for vehicles on Mars and for rockets to be able to return home. Fuel can be extracted from the carbon dioxide in the atmosphere and water. All this has to be done in completely unfamiliar conditions. Gravity on Mars is 3 times weaker than at home. You'll be able to jump higher and lift heavier objects, but prolonged exposure to such weak gravity can harm our bodies. Now that there's a whole city on the planet's surface, it's time to turn Mars into something more comfortable, resembling Earth. This is called terraforming. We need to increase the pressure in the atmosphere so that water can exist here not only as a vapor or ice, but also in liquid form. We also need to raise the temperature of the surface. Our goal is about 68 degrees Fahrenheit. Right now, it's about -81 degrees Fahrenheit on average there. Then, we need an ozone layer, like on Earth. It should protect us from solar radiation. Finally, we can start creating the biosphere. That's all living organisms, plants, and animals. Gradually, Mars will start to resemble Earth in its best years. For all this, scientists have come up with many solutions. For example, a large asteroid could be dropped on the surface of Mars. This would warm up the atmosphere and bring more water and gas there. The planet could also be populated with different bacteria. In laboratories on Earth, scientists have simulated conditions on the surface of Mars and realized many bacteria can survive there. As long as they live, they can release oxygen and other gases into the air. Besides that, we can build biodomes. This is a kind of greenhouse with favorable conditions. Life will develop in it, and the soil of Mars will gradually become suitable for life. And one of the easiest ways is the greenhouse effect. On Earth, it contributes to global warming, but on Mars, gas emissions from cars and factories can help create an atmosphere. Optimistically, it could take 300 to 1,000 years to change the face of the red planet. Other scientists say it could take millions of years. Only then will humans finally be able to take off their spacesuits and oxygen masks and call Mars home.
Dust storms on Mars can really go crazy. They hurtle through the red planet's southern hemisphere, especially during the summer. These storms can grow and encompass large areas of the planet, as happened in January 2022. Then, a dust storm covered almost twice the area of the United States. Could it be something like this that caused one of the robots we sent to Mars to go missing? The atmosphere and climate are harsh on Mars. It's mostly a desert with strong winds and average temperatures of -81 degrees Fahrenheit. It drops down to -220 at the poles during the winter. A lander needs to be specifically equipped and very sturdy to withstand such conditions. But researchers thought the Beagle 2 could handle the difficult trip to the red planet. June 3, 2003. A team of researchers got one of their pioneering robots they were about to send to space ready. It was a small and compact lander called the Beagle 2. Its mission was to touch down on Mars and search for what the world has been actively looking for decades now: life on the red planet. Now, the touchdown was due on December 25th, but the signal never came. The team tried to contact the spaceship, but at one point, they had to accept they wouldn't be able to reach it. Some thought the landing was too difficult and complex after all, so the lander crashed. But they couldn't find any technical errors. Others had a theory that the lander may have become entangled in its own parachute and fell down to the surface of Mars. Either way, the Beagle 2 was considered missing, until 2015, when NASA took pictures of what could be the remains of the lost lander. They weren't just smashed debris, the components actually looked to be intact. The lander's remains were lying with its solar panels partially deployed around 3 miles away from the site where it was supposed to land. Apparently, the Beagle 2 managed to land successfully, but its radio antenna got blocked. That's why researchers couldn't control it from Earth or communicate with it. But no one knows exactly why it happened. Have you heard of a face on Mars? In the 1970s, one of NASA's spaceships took the iconic images of the Martian surface that showed a face-like formation, as you can see in the upper part of the picture. If you have a rich imagination, you can easily see a nose, 2 eyes, a mouth, and an unusual hairdo. Some even thought it was a monument built on the red planet by another civilization. How about some other unusual things people have found on Mars, like Happy Face Crater? You can easily see why it has this nickname. Or rocks in different shapes, a pancake, brachiosaurus, or a fish. Mars also has a waffle-shaped island on its surface. It's a 1.2-mile-wide feature you can see in the area of lava flows. It might be the result of lava pushing this formation from below. It seems astronomers have also got some images of blue dunes. It's a sea of stunning dark dunes that strong winds sculpted into long lines. They surround the planet's northern polar cap and cover a region as large as Texas. The red planet is usually known for its brown sandy dunes, so these ones certainly came as a surprise. In reality, though, they're not really blue. If you could visit Mars right now just to take a look, you'd see that these dunes appear brown and orange like the rest. And the picture is a false color image. Scientists often use false colors to highlight differences in something. For example, here it's the difference in depth. Also, the biggest valley on Mars is so large it could eat our Grand Canyon for breakfast. It's a fascinating system of canyons 2,500 miles long called Valles Marineris, and it's over 10 times as long as the Grand Canyon. Now, if you could stretch this Martian canyon, it would go from coast to coast of the entire United States. Since Mars doesn't have any active plate tectonics, no one knows for sure how this canyon formed. One theory says a chain of volcanoes located on the other side of Mars, the one that includes Olympus Mons, bent the crust from the opposite side of the planet. This powerful force caused cracks in the Martian crust as well as activated enormous amounts of water lying under the surface. This water then emerged and carved the rock away. The force activated glaciers too, and they possibly created new pathways in this gigantic canyon system. Volcanoes on the Martian surface could have erupted about 50,000 years ago, although the most powerful eruptions happened 2 to 3 billion years ago. But the planet doesn't have active volcanoes today. Most of the heat stored in its interior during the planet's formation has been lost. So now, Mars's outer crust is way too thick for the molten rock to reach the surface. But a long time ago, eruptions formed giant volcanoes, and these volcanoes most likely had an important role in melting ice deposits, which released floods of water onto the Martian surface. Now, Mars has a thin atmosphere with a volume of gas, mostly carbon dioxide, less than 1% of Earth's. But 4 billion years ago, it was way warmer and wetter than now. Its atmosphere must have been thicker back then, too. That's why it could create a powerful greenhouse effect and trap sunlight. Mars also has a powerful magnetic field. Similar to Earth's, it formed because of the currents of molten metals in the planet's core. But unlike our home planet, Mars lost its magnetic field after its core had cooled down. And without it, the planet didn't have any protection from the solar wind, which is a stream of charged particles flowing from the sun. The solar wind pulled away most of Mars's atmosphere in just a couple of 100 million years, give or take. This is what makes those powerful Martian dust storms even more intense. Mars has a fascinating history. Judging by the planet's glaciers, Mars has probably gone through multiple ice ages, just like Earth. A team of researchers got images of about 60,000 Martian rocks. Rocks were different in size and distributed randomly, which means they probably formed during different ice ages. Glaciers hide their own stories too. Who knows what kinds of gases, rocks, or even microbes could be trapped inside? Now, if you could get into a time machine and stop at 4 billion years ago, on Mars of course, the chances are you'd see spectacular scenes of flooding. Maybe there would even be some form of life on the planet's surface. A strong meteorite impact that formed the red planet's Gale crater could be something that triggered that mega flood. After that collision, the temperatures on the planet got insanely hot. This caused the melting of all that ice that was stored on the Martian surface at that time. The flooding was so massive, it changed the geological structure of the planet's surface. It carved out big ripples, as well as waves in the sedimentary rock. Now, speaking of water, vapor has been noticed escaping the atmosphere of Mars. Also, researchers have found some evidence of water flowing on the planet's surface. There are dark streaks in the soil. They seem to get bigger in the summer and shrink over the winter. There are numerous dried-out valleys and river channels on the planet. It's possible that liquid water once flowed there. Now, most of it could be locked up in ice caps or even hidden under the surface. More and more things hint that Mars used to be habitable. Mars is the only planet we know about where only robots live. 5 rovers make up the Martian population. Those are Perseverance, Opportunity, Spirit, Sojourner, and Curiosity. These robots are there to take pictures and samples of soil and air, and maybe even find life on the red planet. And someday, we may reunite with them on Mars. Who knows? Oh, and by the way, if you really could get into a time machine and stop at 4 billion years ago on Mars, then I'd like to buy you lunch and talk about it. My treat. It's staring at you, and you're staring at it. A giant eye that seems to be pulling you into an abyss. You're hovering over it in your space copter. But however scared you might be, you still need to do your job. So you send your copter down to the surface of the red planet. Right, that's where you are, on Mars. But first things first, you take a moment to remember everything you know about the 4th planet from the Sun. It's the last of the inner planets. Those are the planets that lie within the asteroid belt. They're also called terrestrial, since they're made up of rocks and metals. The atmosphere of Mars is much thinner than Earth's. It contains 95% carbon dioxide and a mere 1% of oxygen. In other words, don't even think about pulling off your helmet. Anyway, there's no time to waste. You land on the surface of the planet and find yourself in a brownish-red world. That's a good thing you're wearing a spacesuit. This place is freezing cold. The thermometer sewn into the sleeve of your suit shows minus 80 degrees Fahrenheit. Time to take your first step on the Martian surface. The planet looks quite colorful, and the hue of a particular area depends on the minerals that make up the soil. The ground under your feet is covered in fine dust. It looks like rust. The same orange dust is in the air. Good thing you have your own supply of oxygen and don't need to breathe Martian air. The layer of this dust covering the surface of Mars can be from 6 to 40 feet thick. You hope you'll avoid getting swallowed by some Martian quicksand. You start walking, feeling very light. Mars is just 15% of our planet's volume and a mere 11% of Earth's mass. It means that gravity here is much weaker. Its pull is 38% as strong as the pull of gravity on the surface of Earth. You jump up and down and then try to run several hundred feet. Ha! You haven't even broken a sweat. What makes it harder for you to explore the place on foot is that the planet's surface is rocky, covered with craters and volcanoes, old dry lake beds, and canyons. You see something huge towering on the horizon, but you try to suppress your curiosity. You'll have enough time to figure out what it is later. Suddenly, a massive cloud appears in the distance. It looks as if a huge herd of horses is approaching you. In reality, you better get back into your copter and fly away as fast as you can. That's one of Mars's infamous dust storms. They mostly occur during the summer in the southern hemisphere of the red planet. They can sometimes cover the entire planet, and you see the largest ones from Earth. You hop into your copter and set a course for the eye that scared you so much. Winding channels that look like veins run through the eyeball. But the closer you get, the less it looks like an actual eye. Soon you realize it's a crater. It's giant, almost 19 miles across. Around the crater, which looks as if it has a pupil, there are other even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once there was Martian water in the enormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Now, remember that towering something on the horizon? It's time to go and explore it. When you come close, you realize it's the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which is almost the same size as the state of Arizona. You tilt your head. Wow! The mountain is 16 miles high. It's also rimmed by 4-mile-high cliffs. To picture the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, towering around 2.5 miles above sea level and stretching 75 miles across. Sounds impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. But why is this volcano so large? It might be the result of lower surface gravity and higher eruption rates. Or the reason might be the red planet's crust, which is very different from Earth's. It's static. You see, on our planet, the crust is made of 15 to 20 moving tectonic plates. As plates move over hotspots producing lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. So, how about getting closer to the enormous mountain? But once you step out of your copter on Martian soil, the ground under your feet starts shaking. Well, that's a Marsquake. But how can it happen if Mars doesn't have any actively shifting tectonic plates? Specialists from NASA are sure Marsquakes occur when energy inside the planet gets suddenly released. It leads to rock fractures and cracks in the planet's crust. Another powerful jolt, and one of such cracks opens right next to you. You fall to the ground, afraid to move, but soon everything calms down. You wait for a couple of minutes, just to be sure, and get up. Oh look! Here's a perfect opportunity to explore the insides of the red planet. The crack is large enough to send a special research robot. The planet's crust is thin and consists of volcanic basalt rock. The mantle that surrounds the core of the planet is made up of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1100 miles thick. As for the planet's core, it's made mostly of iron, nickel, and sulfur and is between 900 and 1200 miles wide. This core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. Unfortunately, your drone is now lost in the depths of the red planet. You leave it there and continue your exploration. Your next destination is Valles Marineris. It sounds more like an Italian red sauce, but it's actually an enormous canyon, or rather a canyon system, that runs along Mars's equator. It's as awe-inspiring as Olympus Mons, more than 2,600 miles long and over 4 miles deep. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Now let's make another comparison. One of the most famous canyons on Earth is the Grand Canyon in Arizona. But it's 10 times shorter and around 4 times less deep than this canyon on Mars. Some scientists think that Valles Marineris is the edge of an enormous tectonic plate. It moves so slowly that almost nothing has happened in that region over millions of years. and the movement of this plate probably began 3.5 billion years ago. Anyway, the only thing left on your today's to-do list is to visit Mars's moons. They're among the tiniest in the solar system. Phobos is the largest of the two. It orbits a mere 3,700 miles above the surface of Mars. There's no other known moon that travels closer to its mother planet. It whips around the red planet 3 times a day, while the second moon, Deimos, needs 30 hours to complete one orbit. Phobos is getting closer and closer to Mars, about 6 feet each 100 years. Within the next 50 million years, it'll either crash into the planet or break apart and form a ring. Happy but tired, you return to your spaceship. Tomorrow, you'll continue exploring the magnificent red planet, and who knows what discoveries are awaiting you. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.